quote Han Solo yet again, this is where the fun begins. All right, so for 5, we're going to be using exponential functions to model data. And you know by this point that modeling doesn't mean, Heidi Klum. It means taking real life data and trying to find a curve or a line that approximates it. Speaking of which, let's read that. An exponential model is an exponential function, or its graph, that describes the relationship between two quantities in an authentic situation. If all of the data points for a situation lie in an exponential curve, then we say that the independent and dependent variables are exponentially related. If no exponential curve contains all the points, but an exponential curve comes close to all of the points, and perhaps contains some of them, then we say that the variables are approximately exponentially related. Okay. Very similar to what we did with linear stuff. We're going to have a scatter plot or something like that. And if there's a curve that comes close to them, then that would be exponential, an exponential curve that comes close. Or linear if you're still dealing with chapters 1, 2, and 3. And there will be another one in quadratics in chapters 6 and 7. So let's read this problem. Suppose 4 people arrive home today in Michigan from a trip abroad with a new type of flu. Suppose that each day the total number of people who have the illness triples. Okay, now think about what that means. That means that if the total number of people triples, that means that each person infects 2 other people each day. There's an important distinction there that I want to get at, but we'll talk about it a little bit later. And the f of t be the total number of people who have the illness t days since today. Find an equation for f. Okay, so f of t is equal to, now remember these are going to be a, b to the t. Now a is your starting amount. It's your y-intercept. So it's got to be 4 because we started off with 4 people. Now it triples, okay, so you need to multiply it by 3 to the t. There you go. And we better make notes to ourselves because you won't remember where any of this came from. So note, right, starting value equals 4 people. So let me see, a equals 4. Sorry, integral a equals 4. And then triples means times 3, which means b is equal to 3. Okay. Now, think about what this means for just 1 second. Make another important note here. Okay. If b is equal to 3, that means you gain 2, right? Because you take, here, 3 take away 1, which is 2. Because let's say if one person has it, then the next day 3 people have it. Okay, so the one person isn't a gain. They already had it. The persons you're gaining is the 2. Okay, just keep that in mind for later. So this is a note for later. So the gain is actually 3, or excuse me, 3 take away 1, which is 2. So the base is 3, right? Totally 3, that's fine. But I just want you to kind of to make a note of this for later. That means your gain, how much you're actually growing by, is 2. Okay, so make notes of all of that. Important stuff in there. I wouldn't have said it otherwise. Okay. Now, how many people have the illness in a week? Well, this isn't hard at all. You say, okay, f of t was equal to 4 times 3 to the t. So we want 1 week later. So that's 4 times 3 to the 7. Now, the one thing I will warn you about is that, well, I'll warn you about a lot of things, but you want to type this in 4 times 3, parentheses is fine, to the 7, like this. What you do not want to do is go 4 times 3 is 12, and 12 to the 7. You see how wrong that is? Now remember the order of operations, right? Order of operations is, please excuse my dear Aunt Sally. Sorry, what was that number? 8748. Okay. 8748. People. Let me fill this out first before I finish my comment. Okay. Order of operations says, please excuse my dear Aunt Sally, which means you have to deal with exponents before you can do multiplying. So you can't go 4 times 3 and make it 12 because that's multiplying, and you have to do the exponent first. Of course, if you type it in the calculator all at once, the calculator knows that and will do it correctly. Okay, now what about 2 weeks? 2 weeks would be 14 days away. So let me go back to the calculator because I don't know what this is off the top of my head. 4 times 3 caret 14. 191 31876. Oopsie. 191 31876. If I put commas in there, it helps. You can see it's 19 million, which is actually larger than the state of Michigan, I believe. The entire state is affected, which shows you how dangerous exponential growth is, right? And I know what you're thinking. You're thinking, oh, how realistic is this? Well, perhaps not for the flu, but if it was a pandemic flu, yeah, this is one of the big concerns of the CDC, the Center for Disease Control, right? They don't want viruses to spread, which is why they've struggled so hard to get people vaccinated at flu time and stuff, right? Because they don't want a pandemic like the Spanish flu was after World War I, okay? Because it can spread so quickly. And it might be easier to think of this as like a virus to a computer. If you download, if 4 people download the virus today and the number of people who have it triples, then within 2 weeks, 19 million computers have that virus, right? It's a lot, right? Exponential growth, right? So note, exponential growth gets very large very quickly, which is what separates it really from linear growth. All right, so let's look at this. If y is equal to ab to t is an exponential model where y is the quantity of time t, then the coefficient a is the starting value. We already said that at time 0. That's how we got the 4 right there. Now, keep in mind how this works for interest, because that's a big one for us. Your growth in your bank accounts, your savings accounts, your retirement accounts, that's all exponential growth. So if you have R% interest compounded annually, that means that the investment earned each year equals R% of the principal and any interest earned in previous years, right? So it basically compounds and compounds, it gets bigger and bigger and bigger, okay? So remember that we learned this back in section 4.3. It said, look, if I have growth, then I need to be going up, right? If I have decay, I need to be going down. And the big key on that is that you'll grow if your b is greater than 1, and you will decay if b is between 0 and 1. And these are always with a being greater than 0 because real life would be greater than 0. So let me make you up a couple examples. Hold on one sec. All right, let's start with this one. Suppose I'm going to invest in an account, $100 in an account that has 5% annual interest. Let's figure out what the function would be. So most students know, they think, oh, okay, it's 100 for sure, right? And they get that it's exponential growth. But the mistake students make is that they'll say, oh, it's 5% interest, so it's 0.05. Let me draw you a picture of what that would look like. Hold on. Here it is. So hopefully you can see that. So it's problematic, right? I mean, you're putting money in an account to make it grow. But if you make it 0.05, that actually shrinks because of the property that's on this page. It says, look, if you put in a number between 0 and 1, it's going to go down. And look, this computer program doesn't lie. I put in 100 times 0.05 to the x, and look what it did. Shrinks. No good. Okay, well, to make it grow, it's got to be bigger than 1. See that? Larger than 1. Now, the problem is that you need to accommodate all of your initial investment. And that's where 1 comes in. See, now look, if I put 1, just 1 by itself, let me just show you what that would look like. Hold on, make you a picture. So if I say, okay, look, times 1 to the x, it makes a horizontal line like that. It's flat-lined. It's the equivalent of putting your money in a mattress, right? It's not going to grow. It's not going to do anything, right? So that's why it shows you, look, b is greater than 1 grows, b is less than 1 it shrinks, not b equals 1, because b equals 1 is flat, right? Doesn't grow, doesn't decay, doesn't do anything. Diddly squat. Okay? But you need the 1 because you need 100% of that $100 back. You say, look, I've got to have my $100 back, but I need extra. So I need to be 1.05. Let me pick a different color here. Green. And that's what it'll look like. It's going to grow, right? And I know you're thinking, well, that's not a lot of growth. No, not in the short term. But in the long run, it gets bigger and bigger and bigger, right? So that you take $100 now and 30 years down the road, it's off the screen, right? It's way past, the amount that you started with. Let me show you. There we go. $100 invested now, 30 years from now is worth what? Say about $425. See? And the same thing works with larger amounts. Okay, so we need this to be 100 times 1.05 to the t. Right? And let me draw you a quick picture. I'll be right back. There we go. So let me see if I can make this as clear as possible, right? So, and by the way, this was a growth example, so I thought I'd clarify that because I'm going to do a decay example in a second. But if we have $100 invested in an account, it would look like this. It's got to grow. You need 100 times 0.05. So 100 is your starting amount. Equals A. That's pretty easy for most people. Okay? And then the hard part is the B, right? Your growth rate. You're growing at a rate of 5% each year. So that's how you would explain it. So this is the interpret part, right? You're growing at a rate of 5% each year, but that means that B must be equal to 1 plus 0.05, which is 1.05. You've got to be bigger than 1 in order to grow. 1 is flat line, 5% is the interest. Okay? All right, let me type up a decay example and I'll be right back. All right, now we're going to decay here, right? Going down. So suppose you invest $100 in a stock that is losing 5% each year. Now you may be thinking, why am I doing that? Well, sometimes you buy when it's going down and because you think it'll go up eventually or whatever. But bear with me here. So you're going to be doing this. So it can't be the same function anymore because this is growth the way we have it right now. So you might be thinking, aha, Lana, now is the time for that 0.05. Au contraire. So let me show you what 0.05 looks like. That's what it looks like. And I can zoom in. Hold on one sec. Oops, I'll do it this way with the table. And again, you could do this with your calculator, by the way. There's nothing magical about what I'm doing. I could go to y equals, clear out my old equations, type in my new one. Here, I'll put it up here. There we go, 100 times 0.05 to the x. But what I really want you to see is the table here. So if you look at 0 to 1, so at the 0 year, you start out at $100, right? But at the end of the first year, you have $5 left. And that's what this little table right here is showing us. That is not good, right? That's not losing 5%. That means you've lost 95%. You see the issue? You need to lose 5%. So 0.05 is no good because you're decaying by 5%. So you want to take 1 and take away 0.05, which gets you 0.95, right? So you decay 5% each year, which means you have 95% left. If you lost 5%, you still have 95% sitting there, right? Let me try that graph. So let me cancel this for a second. Let me type 0.95. That's much better. Still losing, but not losing by as much. And if I bring the table up, ooh, and I could do it with your calculator too. Again, I just fiddled around with this computer screen. So if I make this 0.95 instead of 0.05, let's see what happens. When I go to the table, see at the end of the first year, so 0 years it's 100, but 1 year it's $95. That's right. That means that I lost 5%. That's what I wanted to say. I didn't want to say I lost 95%. Right? So that's how you do it. You say, okay, it's 0.95. Right? Let me grab a picture of it. It's not a pretty picture because, of course, you wouldn't want to stick with an investment like that in the long run. But it's still going down. Because the B is smaller than 1, it will decay. This B is greater than 1, it will grow. And what you do is when it's growth, you add it to 1. And when it's decay, you take it away from 1 because 1 is your flatline value. All right, I hope that explains all that, and I'll see you back here for the next problem.